All right, so let's take a look at problem 1 here. This is from section 4 of the same diagnostic exam. Without further ado, let's get into it. Great. So problem 1 says John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout, and we want to find out on which interval is the target heart rate strictly increasing and then strictly decreasing. Okay. So essentially what that means is we want to find the interval, right? So it could be like between 0 and 10 seconds. It could be between 80 and 90 seconds where we don't have anything like this happening. So when there's a straight line on the graph, there's nothing increasing or decreasing. Like for the best way to think about this is like when the graph is up like this, it's increasing. And when it's down like this, it's decreasing. And when it's like this, flat, it's not increasing or decreasing, right? So for instance, here, this is not strictly increasing or decreasing, and here the same thing, right? So the only place this is strictly increasing or decreasing by this definition of like this is increasing and this decreasing, therefore for something to be strictly increasing or decreasing, it would have to be straight up and straight down, is this interval here, right? Because there's no point where it's flat. And because of that, our answer is B, which is 40 and 60 minutes, or rather between 40 and 60 minutes. John's heart rate is strictly increasing then decreasing. Great. So number 2 states, okay, so we're given a line. So if y is equal to kx, right, where k is a constant, and y is equal to 24 when x is equal to 6, right, then we want to find, okay, what's the value of y when x is equal to 5? So essentially what we have to do is here is they give us information, right, and we can use that initial information to solve for k. And once we solve for k, then we'll be able to plug in x to our finished equation, because if we know what k is and we know what x is, then we can easily find y, since k multiplied by x would just be a number there. Okay, so y is 24 and x is 6. So we know that's true. So that means that, right, 24 for y is equal to 6k, right? Just by the information we're given, and they say that, they tell us it's true, right? And therefore, if we divide by 6, we know k is equal to 4. So now that we know k is equal to 4, we know this equation is actually y is equal to 4 times x. All right, since we know the full equation now, they're asking us for y when x is equal to 5. So when x is equal to 5, right, what does that mean? That means that y is equal to 4 times 5. And that means that y is equal to 20. Final answer 20 there, it's C. Right, it's pretty straightforward. This is a lot like some of the functional problems from section 3, where you're given, 2 or more parameters, you plug them in, you get your finished equation here. Finished in terms, meaning that it only has 2 variables in it, and then you can simply just plug in x and get the final answer. Okay. Number 3, we have a little bit of a geometrical problem. So it says, in the figure above, lines L and M are parallel, okay? That means they don't intersect, and lines S and T are parallel, right? So basically, the drawing here is accurate. So S and T parallel, L and M parallel. They just create this shape in the middle here. They tell us that the measure of angle 1 is 35 degrees. It's got to label that. And they tell us, okay, we got to find the measure of angle 2. So it's important to know a couple of geometrical sort of principles here that will allow us to solve this problem. So when you're dealing with parallel lines and other things in geometry for that matter, you can kind of make statements about them. For example, a good thing, we're going to use some theorems of geometry to solve this problem, right? Actually, I think it's a better way, since geometry is kind of a vast subject and there's a lot of information to be kind of absorbed with that subject. It's probably better to solve it just with a few simple definitions, right? So a parallelogram, right? We have a set of 4 intersecting lines, right? When you have 2 pairs of intersecting lines like this, they create a shape called a parallelogram, right? A parallelogram is a quadrilateral. That means it has 4 sides. And also another property of a parallelogram is that all of the sides within it, they'll add up to 180 degrees, right? So the first step here is, okay, so what is the measure of this angle here? Well, these 2 angles are what's called vertical angles, which means that they will have the same measure. So any 2 angles created by a pair of intersecting lines like this will have the same measurement. So therefore, this angle is also 35 degrees, right? Great. And now, since we're dealing with a parallelogram, parallelograms, this shape in the middle, created by two pairs of intersecting parallel lines, have a property where their opposite angles are actually congruent, which means these angles are the same measurement. That's just a property of a shape created by two pairs of intersecting parallel lines, right? For those who are more interested in Google properties of parallelograms, and you can get all the information you need. The key is just knowing geometrical terms to solve this problem. Great. So then from there, we know that this angle here is also equal to 35 degrees. And if we kind of take this as a diagram here, right, this is angle 2, and we know that this angle is 35 degrees. And since these angles, they make a line, right, then we know that the sum of the angles must be equal to 180, because a line like this has a measure of 180 degrees, right? Just another geometrical fact there. And so when we add them up, we'll just say, okay, the angle 2 plus 35 equals 180. So the measure of angle 2 is equal to 180 minus 35, which is 145 degrees. Okay, so that problem can be a little trickier, but the key here is just reviewing geometry. You can also use transversals to solve this problem, but it's a bit more complex than just knowing some properties of a shape like this. So yeah, that's number 3. Okay. Number 4 is a kind of a pretty basic equation problem, but the key here is sort of breaking down the words they're using, right? So it says if 16 plus 4x is 10 more than 14, so the is here, right, refers to an equal sign, right? The value of 16 plus 4x, right, we're kind of just breaking down the words here, is equal to 10 more than 14, which is more than 14. That's 14 plus 10, right? So great, we've kind of broken down this problem into an equation sort of term. That's the key here, like deciphering the writing, right? And they want us to find out the value of 8x. Okay, so that's pretty simple. All we need to do is manipulate the algebra a little bit. That's going to give us 24 equals 4x. Let's rid of that, equals 4x. And of course, if we subtract 16, then we get 4x is equal to 8. And therefore, if we multiply both sides by 2, then we'll get 8x is equal to 16. So there's our final answer, C. Right, when they give stuff like this, like it's just kind of important to understand, like, okay, the is referring to an equal sign. Just use kind of logic here, right? If it's an is, it's probably the same quantity, right? But there's not really a set way to do these problems. It's more just practicing, like, okay, how do I convert words to math, right? Great. Problem 5, it says, okay, which of the following graph shows a strong negative association between D and T? So for here, you're kind of just going to need to know what an association is in these contexts. So there's really 3 kinds of associations, and they're all based on how lines look, right? Like as some of you may know, right, in a coordinate plane, a line like this, where it's sort of it looks like it's increasing, right? Like it's increasing as you input more and more positive values, right? Versus a line like this, which gets smaller as you get more positive. This line grows larger as you get more positive, right? This line here would be considered a positive, a slope, or a correlation. And this line here, down here, is a neg, correlation. Negative. Yeah. So if we examine these graphs, and also like if these were lines that, like, the closer the points are to the line indicates strongness, right? So that means like this would be a strong positive correlation. If the points that you're given are really close to the line, it's strong, right? But if the points you're given are kind of all over the place, right, and they're not really close to anything, that means like there's no correlation. So that would be a no correlation, right? So let's look at the graphs here. We're looking for a strong negative association here, right? So if we draw a line through here, right, we can see there's kind of a negative, like the points are kind of generally, getting closer and closer to the x-axis. They're getting kind of, they're higher towards, our y-axis here. They're kind of sloping downwards they're kind of sloping downwards. They're kind of fit around this line very loosely, right? If we were to look at this one sort of follows a curvature like this. This wouldn't be considered any sort of meaningful correlation, right? It's so flat that it's kind of hard to determine if it's positive or negative. It's more like a straight line. And C, well, C has a positive correlation, right? But it's positive and it's tightly packed, right? So we're not looking for a strong positive correlation. We're looking for a strong negative correlation, right? And negative is slope this way, positive slope this way, right? So D would be our correct answer there because D shows a strong negative correlation, more so than any of these other ones. A could be a fake answer here. Yeah, pretty much. All right, so let's move on to question 6. So 6 is sort of a conversion problem, right? But it's fairly straightforward. All we have to do is use the data they've given us, and we have to do some conversions. So it says a hospital stores one type of medicine in a 2 decagram container. So that's a 10-gram container. So we'll say it's a 20-gram container just for convenience. That's what they're storing their medicine in. Based on the information given in the box above, how many 1 milligram doses are there in the 2 in this container, right? Well, since we've already converted to grams, we know that 1 decagram is 10 grams. Therefore, 2 decagrams is 20 grams, right? We also know that 1 gram is 1,000 milligrams, right? So this would be 20 times 1,000, right? Milligrams, because 1 gram is 1,000 milligrams. It's a container. And then if we just compute that, it's 20 times 1,000. Sorry, 1,000, which is an answer of 20,000, and that's in milligrams, or mg for short. So your answer would be D. The only reason that this would be missed is for an incorrect calculation. Like these are all trap answers, sort of. It's a fairly simple problem, but D is the correct answer. All right, number 7. Number 7 says, okay, rooftop installations in 5 cities, right? So they say the number of rooftops with solar panel installations in 5 cities shown is shown in the graph above. If the total number of installations, so all these added up, is 27,500, right? So assuming like if we added up all these little things here, right? So we have city A, B, C, D, and E, right? And this axis is going to represent something, right? What is an appropriate label for the vertical axis of the graph like? So if this is representing the total of solar panels, right? We're being asked to find, we're being told that the total, right, is 27,500. That's what we're being told the total is, right? And we know that they're installing in these 5 cities. So the y-axis here, it's clearly representing quantity, right? Because if it wasn't, what else could it represent, right? Since this graph is giving us information of how much, maybe this is here, this is 500, maybe this is 10, right? These stacks here have to represent quantity because the information the graph is telling us is like, okay, the graph is telling us how many installations there are, right? Now the question here, since they tell us these are all, so we've nailed out that these are all number of installations, right? Great. So this is some number of installations. Installs, right? But they give us units here that are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And so what they're asking is the unit tens, hundreds, thousands, or tens of thousands, right? Because if this was tens, right, then this would be 100 or 10, 20, 30, 40, 50. This top number here would represent 90. City A would have 90 installations. Well, it really can't be tens, right? Because if it was tens, then we wouldn't get anywhere close to 27,500, right? So it can't be tens. What about if it was hundreds? Well, if it was hundreds, then the max would be 900, right? So we still wouldn't get anywhere close to 27,000, right? Now, if it were 1,000, right now, if this 9 up here represented 9,000, and the answer is C, right? If this was 9,000 and we added these together, then it would be 9,000 plus 5,000 plus 6,000 plus 4,000 plus 3,500. That's going to equal 27,500. So because the labeling is in single digits, the actual sort of label of this axis would have to clarify thousands to make this correct, right? So it's kind of just a logic problem here. Nothing too crazy, nothing involving anything outside of nothing involving any mathematical, really fancy stuff. But yeah, just kind of make sure to read the problem correctly. Okay, so 8 is an absolute value problem. So it says for what value of n is, I'll just write this over here a little more neatly, n minus 1 plus 1, sorry, the absolute value of n minus 1 plus 1 equal to 0. Okay, so absolute value, so these bars represent absolute value. So the absolute value of a number, let's call it x, is the numbers for those of you who may be unfamiliar, distance from 0. So the absolute value of 2 is 2, right? Because 2 is 2 away from 0. That's 2, right? So that's 2. And the absolute value of -2 is also 2, because -2 is just 2 away from 0. So absolute value is always positive. And so if we look at this equation here, this is actually a fairly simple problem, because if we look at this equation, right, and we rearrange it, right, then we get the equation, the absolute value of n minus 1 equals -1. Well, we just said down here that, okay, absolute value is always positive, so how could absolute value be negative? And the answer is, well, it can't, right? There is, in fact, no such value of n, right? Because think about it, right? If I plug in a 3, I plug in any value at all, right? This will always become positive. It'll always become larger than -1. In fact, the smallest this could be is 0, right? And so because of that, we don't have a solution. All right, great. Okay, questions 9 and 10 are just kind of, question 9 at least is you're sort of manipulating equations. So it says, the speed of a sound wave in air depends on the air temperature. And we're given this formula where A, the speed of the sound wave in feet per second, relates to T, the temperature in degrees Fahrenheit, right? So we have A is equal to 1052 plus 1.08 T. So they're asking, which of the following expresses the air temperature in terms of the speed of the sound wave? A. So what we have to do here is just kind of apply knowledge of algebra. So we just say, okay, A is equal to 1052 plus 1.08 T. And I'd say, okay, I want to isolate T. So the first thing I want to do is subtract 1052, 1.08 T. Great. And now I still have to deal with this 1.08. So all I would end up doing is dividing both sides by 1.08. 1.08. Great. And then that would leave me your final answer of A minus 1052 over 1.08. And that's equal to T. And if we look at our solutions, that's A, right? So the only key to this problem is like understanding algebra. Really, that's all it is. Understanding, okay, this, I divide both sides by this, and the SAT has a lot of these. So it's a good idea to practice, like, okay, if you had something like x plus 2 is equal to y, 3y or something, and you want to find y in terms of x, right? Then you could get, or you want to find just y, you could divide both sides by 3, right? Then you get y. So stuff like that, like this, they'll have you do stuff like this. It's also a very useful skill for solving systems of equations, right? Because it allows you to isolate certain variables by themselves and then have a chunk of something on the other side, right? Okay, let's move on to the next one. So it says, at which of the following air temperatures will the speed of the sound wave A, right, be closest to this? So let's take a look. So if we say, we remind ourselves of the equation, we want to find out, okay, what will the temperature be when A is 1,000, basically? Because if we plug in A for 1,000, right, then we'll find a value of T that's going to be very close to one of these, right? So we want the speed to be 1,000. We want to find out what T is when the speed's 1,000, because it says that which of the following air temperatures will the speed of the sound wave be close to 1,000 feet per second. We can plug in 1,000 for the speed and solve from there. So 1,000 is equal to 1,052 plus 1.08 T. We subtract, we'll get negative 52 actually is equal to 1.08 T. And if we divide, pull out your calculator, do this. So if we divide and we solve, we will get an answer of negative 48 approximately. Not exact, but approximately. And that's in degrees Fahrenheit. This answer will be negative just by the nature of the problem, and that is B. They give you some other close ones. The important thing here is remember the rounding rule, right? If it's less than 0.5, what's that? Yeah. And you round down, and if it's greater than 0.5, you round up. Greater than or equal to, I should say, right? That's how you get your answer. That's how you avoid picking wrong answers like that, right? Great. Let's move on to question 11. So it says, which of the following numbers does not solve this inequality? Right, so sometimes on a test, the quickest way to solve this can be to guess answers, right? You can always guess answers, right? Like you can always plug in 1 for x. But if you want to actually solve this, right, we can actually solve it as an inequality, right? So let's rewrite the inequality out. Is greater than or equal to 4x minus 3. And so we can, the only time that this sign will change is if we're multiplying or dividing by a negative, right? So what we can end up doing is actually, well, we can just consolidate both sides. So we can, okay, I'm going to subtract 3x and subtract 3x. I'm going to add 3, I'm going to add 3. So that means that x will be less than or equal to, that is a 5, negative 2. Okay, so basically, we're looking for the one number that's not less than negative 2, right? Since we've solved this inequality just by using algebra, right? The only time it's different from an equation is when you have, when you're multiplying or dividing by a negative. Like if you had negative 4x is less than 3, you would solve this by saying x is greater than negative 3/4, right? That's all. So with that in mind, all we need to do here is say, okay, which one is not less than negative 2? And the answer to that is, of course, A, because negative 1 is greater than or equal to negative 2. So that's our solution there. All right, so we're given a histogram, which is like a graph, or it's kind of like a bar graph, but it's basically just another name for it. So number 12 says, based on the histogram above of the following, which is closest to the average, the arithmetic mean of the number of seeds per apple? Number of seeds per apple. So we have to count them here. So we have 2 apples with 3 seeds. So we're essentially going to average together everything, and then we're just going to, it's just a solving problem. So we have 3 apples here, right? We got to take an average. So the average is just the sum of the totals divided by the number of the totals. So in this case, so if we just count them, right, this is just kind of a bit of a nuisance problem, but we have 2 apples with 3 seeds. So that's just going to be 3 plus 3. We have 5 apples with 4 seeds. 5 times 4, simplify there. We have a 6, and we have a 7 times 2, and we have a 9 times 3. And if we count out the total number, it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? And if we calculate this, we will get very close to 6. Right? And that is our solution, right? But it's just really, okay, we have 2 of this, so it'll be 3 plus 3, right? We're just kind of saying, okay, we have 2 apples with 3 seeds. We have 5 apples with 4 seeds, right? And we're just trying to find the average number of seeds per the individual apple. All right, everyone, so let's take a look at question 13. So this question, it gives us a table, and it's asking us, it says, a group of 10th graders responded to a survey that asked which math course they were currently enrolled in. It says the survey data were broken down as shown in the table above, so we're given this chart. And it asks, which of the following categories accounts for approximately 19% of all the survey respondents? So a good way to approach this problem is to kind of look at the numerical values of all of the multiple choice answers and, try to compare them to the 19% here. And the way to do that, right, is if we observe the total of our data here, right, one of these categories, when divided by 310, right, should be close to 0.19, right? Because when we convert 0.19 to a percent by multiplying by 100, that's 19%, right? So we should be looking for a category here, a value here that produces something close to 0.19 when we divide it out. That's basically what this problem is saying. And of course, when you multiply a decimal by 100, you'll get to a percent. So the first one is females taking geometry. So that will be a value of 53 over 10. Great. And we'll calculate these all at the end. The second one is the values of females taking algebra 2. That'll be 62 over 310. C is males taking geometry. That's 59 over 310. And D is males taking algebra 1. Oh, that's 44 over 310. And so if you were to calculate these all out, right, which I'll leave kind of as an exercise, because when you calculate them all out, you'll see that, you know, the closest one here is in fact, it's males taking geometry, right? This one, because this is the closest one to 0.19. So that's the way to approach this problem. They're asking for the closest to 90%, right? And this accounts for approximately 90% of all of the survey recipients. So it's basically just like kind of, okay, a bit of a calculation problem and also understanding what the problem is asking. Great. So let's move on to question 14. So question 14 says, the table above lists the lengths, so it's another table problem, to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement is of 24 inches is an error, so this is an error. Of the mean, median, and range of the values listed, which will change the most if this is removed, right? So we want to know, okay, so there's all this data here, length sufficient inches, that they're going up, right? And if we remove this value, which one's going to change the most, right? So we got to be familiar with the terms, right? Like, so the mean, of course, right, is the average of all the data, right? So if we took all these ones up and we added them together and then we divided them by the total, right, which is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 21, right, we would get our average, right? The median is the value directly in the center of the data, right? So if we cancel this one out, and we went down the line and we found the center of the data, which looks to be around 12, that would be our median, right? The range is the biggest value subtracted by the smallest value, right? And then there's D, they will all change by the same amount, right? And so they're asking, okay, which one will change the most, right? Well, the first thing we can look at is the median, right? So if we were to remove 24 from this data set, there's so many 12s and 13s in the center here, right, that the median isn't going to change all that much. But we can say that pretty definitively. It's either going to be 12 or 13. So the median isn't going to change it that much, even if we remove a number at the end here, right? And they're asking which will change the most, right? So since one isn't changing that much, then we can kind of X out D, right? They aren't all going to change by the same amount. They aren't all being acted on by the same thing. This 24 won't change them all by the same amount necessarily. Like the average might change by a half, for example, and the median will only change by 1. We can't say that definitively, right? So now the question is, okay, will the mean or the range change more? Well, if we look at the mean, right, the mean is an average, right? So one thing you could do is calculate the average by adding all these up and then dividing them by the total number of parts here. But if we look at the range, like 24 minus 8 is 16, and 16 minus 8 is 8, right? So if although we can't say definitively that the mean will change less than the range without calculating everything, it's pretty clear that the range is going to change the most significantly because the average has so many inputs that it's not going to change very much, despite the fact that you're introducing a 24 to it, right? But the range, on the other hand, is going to change by 8, right? And so because of this, although it isn't the most definitive way to do this problem, we can kind of make a very, very good educated guess that this is the correct answer because it's changing by such a significant amount, right? And so by that logic, C is the correct answer. Of course, you could verify this by computing the whole average and by computing the mean as well and by verifying the range. But this is the way I like to think about them. But of course, that is an option. But I'm going to solve this way. All right, let's take a look at question 15. So question 15 says, it gives us this data set. It says questions 15 and 16 refer to the following information. It says, the graph above displays the total cost, C, so it goes from 0 to 20 in dollars, when you rent a boat for H hours. Okay, so our variables are C and H. They want to know, okay, what is the C intercept? That's the point where our line here intersects the C axis. I'll call it the C intercept, open a dot there for abbreviation. Represent in this graph? Does it represent A, the initial cost of renting the boat, the total number of boats rented, the total number of hours the boat is rented, and the increase in cost to rent the boat for each hour? Okay, so let's think about this for a second. So this is our total cost in dollars. So we see this. Let's just take a look at the graph. We see when we're at 0 hours, our intercept is $5, right? And from there, at 1 hour, it goes up to 8. 1 hour. I'm just reading the graph here. We have $8. and so on. This keeps going up. But if we look at our 0 hours rate and we look at our intercept, well, that $5 value is our value at 0 hours. So if we look at our answer choices over here, right, and we look at A says the initial cost of renting the boat, right? Well, you know how like sometimes you can when you rent something, you put a flat rate out, right? This $5 fee has to be delivered before they've used the boat at all, right? So by that logic, this $5 fee is the initial cost, right? Because at 0 hours, they still have to pay $5 to use the boat, right? And so by that logic, we would select A as the correct answer. The rest of these don't really make any sense. We also know that this axis represents cost. So anything that doesn't have to do with cost is not going to matter. And we also know that this doesn't represent an increase, right? Because it's not like one point could somehow tell me how this line is going to increase. The logical answer here is A, right? So let's move on to part 2 of this problem. Part 2 asks, it gives you the graph again. And it asks, which of the following represents the relationship between H and C? Like, what relationship can compare both? Well, so we know right off the bat that well, we have this flat rate of $5, right? So we know that our cost, right, is going to have a 5 attached to it somehow, right? Because our cost is going to be increasing, but it's always going to start with the 5. So we can rule out these two answers here, right? And now essentially we have to say, okay, how much is our cost increasing per hour, right? That'll tell us this number here. Is it 3/4 or 3, right? Because if our cost increases by 3 per hour, when H is 1, it's going to be 8. When H is 2, it's going to be 11. It's increasing by 3 per hour versus with the 3/4, right? A cost is increasing by 3/4 of a dollar per hour. So let's take, since this line is constant, it's always increasing by the same rate. All we have to do is compare 2 of the points, right? So if we look at our 0, right, or this point here, this is this is our flat rate point. So we have 0 hours, and then $5. But if we look at our 1, right, and we did this on the last problem a little bit, here it's more relevant. If we look at our 1 hours, then we have $8. So since this is a line, and all lines have a constant rate of increase, right? That's just a fact about lines. We can deduce from this that, well, we increased 1 hour, right? 5 plus 3 is 8, and that's $3. So this tells us, okay, it's $3 per hour. Oh. After the flat rate. And so by this logic, of course, it's C, right? Because that 3 signifies an increase of $3 per hour, right? That's just a good way to think about this problem. And always consider those variables cost and hours, right? They're just giving us some information about the problem. All right, let's move on to question 17 here. So it says the complete graph for some function f, right? F of x is kind of squiggly line here, is shown in the xy plane above. And they want to find the minimum values for f of x. So for those of you who don't know, a minimum is the value that the function has at its lowest point. So we want to know, okay, what value does this function have at its lowest point? So let's take a look at the graph. The minimum value is so if we look at this graph, right, the minimum value is the lowest point on a graph. This just means it's the most negative. It's the most, and we're referring to y. We're referring to the y coordinate. This just means, like, for example, in this graph, we can identify the minimum as this point because on the y-axis, this point is where the y-axis dips the lowest, right? So this is our minimum. That's just the definition, and it's good to do some practice with these, but that's our minimum point. And so now they're asking, okay, so for what value of x is this minimum? This minimum is valued at -2 right here, but they want to know what value of x is does the minimum occur at? So all we have to do there is count 1, 2, 3. It occurs when x is equal to -3. And so because of that, well, our minimum value is, the answer here is -3 because our minimum is occurring when x is equal to -3. So it's a pretty simple problem. You just got to make sure you know how to read the graph, right? Keep in mind that the scale is 1 here, but the scale doesn't have to be 1, so that's kind of an important pointer. And that's pretty much it with those kinds of problems. These do show up fairly common, or problems with functions that look kind of like this, right? They look kind of squiggly, but oftentimes the test doesn't ask very many pressing questions about it. So this is a good thing to note. Okay, let's take a look at question 18. So question 18 says, in the xy plane, if the point 0, 0 solves this inequality, which of the following must be true between these quantities A and B, right? So this problem is a bit complicated, but they do give us some information to kind of start, right? So let's take a look. Great. So, yep. Let's take a look here. So if we plug in 0, we can take both of these equations and plug in 0, 0 for x and y. So this first equation, we get 0 is less than -0 plus a. We also get 0 is greater than b, right? Okay, so right off the bat, we know that a is greater than 0, right? So a is greater than 0. And b is less than 0. Sometimes I like to write it out like words because it helps me think about it better. So because of this, we know that a is some negative value, right? And b is some positive value, right? So therefore, sorry, a is some positive value and b is some negative value, right? Because a is greater than 0 and b is less than 0. So therefore, right, remember in this problem, all we did, we said in the xy plane, if a solution to the system's inequalities above, which of the following relationships between a and b must be true? All we did was plug in 0, 0, right? And we got some information because of that about a and b. So therefore, because a is greater than 0, let's say a is 3, 4, 5, it's something like that, and b is some negative value, -1, 2. Then we can say for certain, right, that a is in fact greater than b, right? Because a is always positive and b is always negative, right? And so that is in fact our answer, because none of these other ones can be guaranteed or are so obvious from the information given. On a test like this, right, we can see clearly that this is the result that comes out of it, right? Some of these other things, you know, may also be true, but they may not necessarily be true. This is the most clear. This is the one that's guaranteed by what we've been given, right? So that's what we can rely on. We can't make any other assumptions, right? We just have to rely on what we've been given. Great. Okay. So question 19 says it says a food truck sells salads for $6.50 each and drinks for $2 each. Then it says the food truck's revenue from selling a total of 209 salads in one day was $836.50. So they want to know how many salads were sold that day. So I'm going to use a couple of variables to represent. I'm going to call my my salads is an S. This is a system of equations problem, and drinks, call it D. Okay. So if we look at the pricing, right, we can make this relationship. We can say 6.5S, right, 650S plus 2D equals 836.5, right? Because this is the total pricing of both things, right? 6.5S plus 2D equals 836.5. Whatever the number of salad and drinks we have, the total price is going to be $836.5, right? And then we can also write a second equation because we also know, well, there's 209 total being sold, right? So we can say S plus D is equal to 209. So we have two equations here and two unknowns, and we can use an elimination or a substitution method to actually solve this. So if we go ahead, right, and we isolate, let's isolate our D here. So D equals 209 minus S, right? That means that 6.5S plus 2 times 209 minus S is equal to 836.5, right? That means that, that's 4.5S equals 836.5 minus this value, 209 times 2, 418. And that means that, well, this is S, right? So it's this 836, that's like 426.5, which gives us an answer of 93 salads. there may be a slight, yeah, that's 93 solids, right? So yes, that is all that is needed for this problem. Sorry, that's not right. 418.5. Great. So 93 solid, that's our solution. We just solve for S, right, with this equation here, right? Great. Okay, question 20 says, Alma bought a laptop computer at a store that gave a 20% discount off its price. The total amount she paid to the cashier was P dollars, right? She paid P dollars, including an 8% sales tax on the discounted price. So which of the following represents the original price of the computer in terms of P? Okay, so we want to find the original price of the computer. So she paid this to the cashier, right? So what we need to do is we need to kind of get back to the original price by sort of removing, right, dividing out by the sales price that she had to pay, right? So they gave a 20% discount. So they gave a 0.8%, 0.8, converting that percent to a decimal, that means she paid 0.8, right? And then if we look at the sales tax that she also had to pay, she paid an 8% sales tax, that's 1.08, right? So the price she paid was this, right? And these are the two taxes that she got this discount. So, right, so she had her original price, I suppose, would be 0.8 times the original, and then she multiplied that by so let's look at it this way. So we have P is the price she paid now, right? And we'll call it R is the original price now. So the original price, right? She had this 20% discount. So we'd have 0.8 times the original, right? Because she's getting a discount. We convert that to a decimal. We're multiplying 0.8 times R, which is the original price, to get that 20% discount that she got, right? We also have an 8% sales tax, right? And so if we add that on, adding 8% onto this would be the same thing as multiplying by 1.08, right? That's adding 8% of R, right? Because this is a percent. We're just taking 1.08% of R, right? And that's going to equal P, right? Because that's the price she has now. So if we want to find the original price, right, now we can divide both sides by 0.8 times 1.08. And if we do that, right, we can see our solution. The key here is just reversing the process from the beginning, right? Great. All right, everyone. So let's take a look at question 21 here, which is dealing with a chart, and we're going to have to make some observations about it and maybe calculate some probabilities. So the question says, the data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random, okay, so we're selecting from the table, from those who recalled at least one dream, then we're asked, what is the probability that that person belonged in Group Y? Okay, so the first thing we have to consider here is, what does that data set look like? People who've recalled at least one dream. Okay, so if we look here, that's pretty much limited to this here, because this part of the table, this 1 or more, 5 or more table, consists of all the people who recalled at least one dream. And it's important to consider the whole thing, right? Because it's not just 1 to 4, it's 1 or more dreams, right? And now we have to look at, okay, so in Group Y, how many people recalled 1 or more dreams? Well, if we look here, we see 11 recall 1 to 4 dreams, and 5 or more recall 68 dreams. So there's 79 people, right, in Group Y. The key with these problems is, again, being able to pull out the data you need, because a lot of times they give you data you don't, right? Here we need to know about Group Y, and we need to know about the total, right? So we say, okay, so 79 people in Group Y have recalled 1 or more dreams, right? Okay, so now in order to find the probability, right, because we're selecting from this whole set, right, we'd have to take 79 and divide it by the total, right? Because we're trying to find out, if we picked a person at random from this whole thing, what's the probability, right, that they would come from group Y? And since there's 79 people in group Y, the probability would be 79 over the total, right? Great, so all we have to do then is count that, right? So our total here is 39, and our total here is 125 for both groups. Again, they've summed it up for us, so we don't have to do a lot of work. So it'll be 79 over 125 plus 39. That simplifies to 79 over 164. And 79 is prime, so that's our fully simplified fraction there. And if we look at choice C, that's the correct answer. So again, common hiccups with this problem might be only considering, considering the wrong data set, but the key here is just reading the problem carefully, right? We're choosing it randomly from this set, and therefore that's the correct answer. Great. Okay. So questions 22 and 23 refer to the following information. Okay, so again, it's another chart problem, right? We have two parts here. This can be a bit intimidating, but the key is just to knock down what you need, right? So it says questions 22 and 23 refer to the following information. Great. The table above lists the annual budget in thousands of dollars for each of 6 different state programs in Kansas from 2007 to 2010. And then it asks in question 22, which of the following best approximates the annual rate of change in the annual budget for agriculture / natural resources in Kansas from 2008, okay, to 2010. We're looking at agricultural / nature resources. We want to find the rate of change. How much is it changing per year approximately? So we have two values, right, at the end of 2008 and 2010, right? And the key with rate of change, right, rate of change is like, okay, how much are we adding to each quantity per year, right? So the key to approximating the average rate of change, they're asking us between 2008 and 2010 is to say, okay, how much does this change per year? So what we can do is, right, if we take 2010, right, we take that 2010 value. We subtract that from the 2008 value. And we're finding the rate of change for 2 years, right? So it's 1, 2, right? We're finding how much it changes in 2 years. So to compensate for that, we have to divide this whole total by 2, right? And in doing this, this will give us a result. So we have to use a calculator. We take this number, 488,106 and 358,708. We would divide that by 2, and then we would get an answer of approximately 65 million. Right? That's all the problem's asking here. It's a bit, we can see that it's not necessarily changing linear. Like here we have 3 being added, and here we have significantly more than 3 being added, but the average there would be calculated using this method. Great. So question 23 asks, of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the human resources program's ratio of its 2007 budget to its 2010 budget? So here is just kind of a numerical comparison. Let's first take a look at the human resources. So 2007, that's approximately 4 million, right? We're just kind of looking at it. These kind of problems, they don't ask you like to calculate it necessarily. They're more asking for the best comparison. So 2007 there, 2010 here. So that's like 4 to 6, right? Because 5.9 is almost 6. So that's almost like 2 to 3, right? We can make a note of that down there. And they're asking us, okay, which one is the most similar? So let's take a look at that. Well, if we look at education right here, right? And we'd have to look at all of them, but education to me here stands out here. We see, okay, this is 2.1 million, and this is like 3, right? Right? And that's a 2 to 3, right? Because the millions will cancel. This is really the same thing as down here. This is really the same thing as 4 to 6, but if you simplify the fraction, you get 2 to 3, right? And so we can see here is that by comparison, right, none of these other ones have the same, like general government, that's almost the same, right? 14 to 14. Highways and transportation, that's nearly the same too. And we can see clearly here that, well, education is the only one with the closest ratio. Something to note here is that when you do problems like this, remember like 4.5, like that rounds up, right? So 4.5 is probably closest to 5, right? And then 4.3, you can round down, right? And you'll be pretty safe with that, right? So the problem is kind of going to help you with that. Like this, that's a good way to make comparisons, right? And that's what I did here, right? Because they round down for 1, and that's what they're usually looking for the solution here. Great. let's take a look at 24. So they're asking our question, which of the following is the equation of a circle with a center of 0, 4, and a radius with an endpoint of 4/3, 5, right? Okay, so here is kind of a more complicated question. They're asking us to apply two principles here. So the first one is the equation of a circle, right? It's a bit more of a complex topic. And then the distance formula. Okay, so the equation of a circle basically just states this equation is x minus k, and we square the whole thing, right? Sorry, x minus h, right? And we square the whole thing, plus y minus k, and again we square the whole thing, equals r squared. So this is like a lot like an equation of a line, right? So essentially, it's a bit complicated, right? Because we don't have y equals something, but essentially what this equation tells us is, okay, this allows us to graph a circle. And the key thing to note here, right, is that h comma k, right, for whatever h and k values are, remember there's a subtraction here, that's important to note, right? If you had addition, h would actually be negative. This is our center. And our radius is r here. This is our radius. But keep in mind, this is our radius squared. So we have an equation x squared, x minus h squared plus y minus k squared equals r squared, right? And where r squared is the radius. Okay, so let's leave that alone for now. Let's take a look at our answer choices. So if we look at A, B, C, and D, we can clearly see they're all in that form, right? You know, h in this case is 0, because if we look at our center, right, it's 0, 4, so h is 0. So we just have x squared plus y minus 4 squared. And so right off the bat, what you can do is actually cancel out these, right? Because if we look here, we see a plus, right? And in this equation, right, a plus here signifies that we actually have a negative y value. The center of this one would actually be 0 and negative 4, right? Since there's a subtraction in the original equation, and a subtraction times a subtraction makes a plus, this is a plus here, and that's why you can immediately remove these answer choices, right? So we can make a pretty good that just helps us eliminate some of these answer choices here. The second step, right? Okay, now we know the first part of the equation has to look something like this, right? Because the center is this, right? Now we have to find out, okay, what's our radius, right? So we're given an endpoint and we're given a center, right? So we have to apply something called the distance formula to find the length of our radius. So remember, if we have a circle, it's a terrible circle. If we have a circle, it's a bit better. Then we have a point that lies on the circle. So this would be like our 4/3. And this is our center, right? 0, 4. Then this distance here, right? Let's call it d, is actually the radius. And once we find the radius, we can plug it in and create our r squared, right? So there's a formula that allows us to find that. And it states that the distance between 2 points is equal to the x minus, sorry, that's not the right way to put it. We do something like, you do the y2, sorry, minus the y1, and that's squared, and then plus the x2 minus the x1 squared. Yeah, that's the formula. Sorry, I threw myself off for a little bit, but in the end of the day, you're taking 2 points, right? You choose one to be your x2, y2, and you choose the other one to be your x1, y1, and then you plug them in. So let's go ahead and apply this. This formula will tell us the radius essentially. So we get d is equal to the square root. I'm going to choose this one to be my my 1, and I'm going to choose 0, 4 to be my other one, right? So we get 4 minus 5 squared plus 4 minus 5 squared, then plus 0 minus 4/3. And of course, we're taking the square root of the whole thing, which simplifies to 1 plus 16 over 9. So that's the square root of 25 over 9, right? Which means that our radius is in fact 5/3, right? And remember, by this formula, right, this is clearly the radius because of the distance between these 2 points. And since this one lies on the circle, this is our radius, right? And so therefore the answer is A, because to write the full equation, it would just be x squared plus the y coordinate here, y minus 4 squared, is equal to 5 squared over 3 squared. That's just 25/3 because it's, yeah, it's 25 over 9, right? Great. Let's move on to the next question here. Okay. 25 gives us an equation. It says h is equal to negative 4.9 t squared plus 25t. And it says this equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? So we can think about this like this. This is some sort of parabolic curve, right? And we want to know essentially, okay, t is our time here, right? We want to know after how many time, this is our time axis, right? This axis represents time, this axis represents height, right? In this graph here, we want to know, okay, after how many seconds will the ball hit the ground? Well, we can figure this out, right? By treating this, we know it faces downward, right? So it's facing downward, and that means that it's going to intersect the x-axis here, right, twice, right? If we think about this from a physical perspective, right, the ball or projectile is it's launched, right? It goes up, and eventually it's going to come back down, right? And so as it launched from the ground, right, it's going to end up back on the ground. Well, those 2 points where it's launched from look an awful lot like our x-intercepts, right? And so the way we can actually solve this is by finding the second x-intercept of the graph, because if we look at this graph, right, if we isolate h, right, equals negative 4.9 t squared plus 25t, there'll be 2 points where time is equal to 0, right? But if we find the second point, right, and we evaluate the distance between the first and second point, we can find how much time it takes for it to hit 0 a second time, right, by finding this x-intercept here. So let's go ahead and do that by setting h is equal to 0. The height will be equal to 0. The time will be some value and some value, right? So we'll get 4.9 t squared minus 25t equals 0. I'm just flipping the sign there because there's a 0 on that side. And then what I can do is I can say, okay, I'm going to factor out a t here. I'll get 4.9t minus 25 equals 0. Okay, so we know t is equal to 0. And then t is also equal to 25 divided by 4.9, right? Because we would solve this equation here too. Well, okay, so we go back to our graph. So that's clearly the 0, right? And then that's our 25 divided by 4.9. Okay, so this is a distance, right? This is how many seconds after the ball will hit the ground. This is the total travel time, so to speak. So because this is a 0 and this is just a 25 over 4.9, we know that this distance here is just, since there's nothing negative, right? This is 25 over 4.9. So let's go ahead and calculate what that might be. So 25 divided by 4.9. Well, let's look at all the answer choices here. It's not 4, right? It's not 3.5. It's not 4.5. It's 5.0, right? Because this is very close to 5. So when we divide it in, it's approximately 5. And that's the answer they're looking for, D, right? This problem is a bit more complicated. It kind of requires one to be familiar with parabolas and also like the logic behind how balls work. Like when you throw a ball up, right? Gravity is pulling it down, or any projectile for that matter, like a rock or something. When you throw a ball up, right, gravity is immediately starting to pull it down. And that's what this 4.9 represents here. Gravity is constantly pulling the ball down, right? But the thing is, you imparted some force on it when you threw it up. And gravity takes some time essentially to get the ball back to the ground, depending on how high you threw it up and what angle and all that stuff. So that's just kind of a basic thing to know. All right. Let's move on to question 26. So it says, Katerina is a botanist studying the production of pears by 2 types of pear trees. She noticed that type A trees produce 20% more pears than type B trees. Based on Katerina's observation, if the type A trees produced 144 pears, how many pears did the type B trees produce, right? Okay, so this is going to be kind of a proportion-based problem, which means, okay, so type A we know is 144 pears, right? And we know that this is producing 20% more pears than type B trees, right? Okay, so it's 144 divided by, we'll call it the B trees, right, is equal to 120 over 100. What this proportion signifies is, okay, basically the ratio of 144 over the type B trees is the same ratio as 120 over 100. These are signifying our percents here, right? So if we go ahead and multiply this up, we'll get 120B equals 144 100, or it's 14,400 if you want to be precise, right? And now we want to know, okay, how many pairs of the type of truths produced? We'll just divide both sides by 120. This will cancel. Right, and then we're just left with a 1440 divided by 12, and that's going to give us 120, which is B. So the key to solve any percent problem is to say, okay, we're given a value of A, right? This is something called the percent formula. That's the formula name, but in essence, all you're doing is saying, okay, I have 144 of these trees, right? And it's if I compare that to B, right, then this is going to equal a ratio that's 120, right, over 100. Since I have 100, since if I converted these both into percents, right, one of them would be equal to 120 of the quantity I'm given, and one of them would be equal to 100, right? So another way to think about this, if you're unfamiliar, is that I guess sort of the part over the whole equals the percent that you want to find over 100, right? But here I applied it kind of differently because we're given a larger percent than what we're at, than something a little less than 100, but you can still apply it the same way. In this case, your whole is actually smaller than your part, but it's the same application. All right, great. Let's move on to the next problem. Oh, great. Another chart problem. These can be kind of tedious, I will say, but again, reading the problem carefully is the most helpful thing. All right, everyone. So let's take a look at question 27. So this question reads, a square field measures 10 meters by 10 meters. So total area would be around 100 square feet. So it says 10 students each mark off a randomly selected region of the field, and each region is square and has side lengths of 1 meter. We also know that no two regions overlap. So we have something like this, right? This isn't exact, but essentially what we're looking at is 100 of these, right? The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region, and they show us some results, right? So they want us to approximate the total, right? So in this data table, we're given 1, 2, 3, 4, 5. We're given 10 samples of data, right? And we can say that, well, there's 100 of them total. We're only given a snippet of 10, and we're basically asked to judge, okay, given this data, how many will there be total, right? So if we have around 100 per square, around 150 per square, if we look at the average, we have 135, 166, we can say, okay, per square meter, rather, there's approximately 150, right? I'm just looking off these numbers too. All of these deal with an approximation of 150 somewhere in the problem, right? So if we say per square meter, okay, just based on this, there's approximately 150, and there's 100 of these. Well, what's that give us? 150 plus 2 extra zeros. That gives us a value of 15,000. So essentially what we've done is we've just taken the data they've given us and we've used that to judge the whole entire this field, right? And so yes, by that logic, the answer would be 15,000. Okay, so question 28. So it says, if the system of inequalities y is greater than or equal to 2x plus 1, and y is greater than 1/2 x plus 1 is graphed in the xy plane, which quadrant contains no solutions to the system? So basically, if we graph this, which quadrant will contain no possible solution? So for those of you who don't know, with an inequality, right, the solution, if we graph an inequality, is the space that applies to both of these. So if there was a number that satisfied both of these equations, right, then that number would be considered a solution to both the equations. And generally, the way it works out with these is that there's a space where the solution set is guaranteed. So let's go ahead and draw these, right? For those of you who don't, I'm going to draw the inequalities. It is a bit different than drawing a line, but we start off with our intercept. We'll call this 1, 2x, so it's up 2 over 1, something like that. That's this one, right? And since it's greater than, we would, since instead of being an equal sign in this line, there's a greater than sign, all of this stuff up here is actually a solution to this inequality. So that's why I'm shading it here to signify that. If I look at the second equation, y equals 1/2 x minus 1, right? Okay, I have a minus 1. That means I go up 1 over 2. Right? Okay, what does that mean? That means that, well, this has solutions all the way up as well, right, past its line. But the question is asking which quadrant contains no solutions to both equations, right? So if I look at this equation, y equals 1/2 x minus 1, and I look at this equation, y equals 2x plus 1, to satisfy both the equations, right, I can only have this solution. And the reason for that is if I shade in between here, right, it's not satisfying this equation because it isn't above it, it's below it, and that's discounted. However, if I shade above both of them, it satisfied both of them because this one's actually lower down, right? It's a bit of a complicated analogy, but the only way to get a solution that satisfies both is to shade above the one that has the requirement, right? Because if I shade in the center here, right, that doesn't solve the first system. But shading above this system, the y equals 2x plus 1, solves both systems. And so they're asking which quadrant doesn't contain any solutions. So, right, well, we can see that quadrant 3 has some shading in it. We can see that quadrant 1 has some shading in it. And we can see that quadrant 2 has some shading in it. The only one that doesn't is, in fact, quadrant 4, right? Because as we said above, as we said earlier, because of the fact that this equation here doesn't actually, it doesn't impact the solution set that much. Right, so that's question 28. All right, so let's take a look at number 29. So number 29 says, for a polynomial p of x, p of 3 is -2. So the question asks, which of the following must be true about the polynomial, right? And so I'll tell you guys, this question is a bit trickier. It doesn't show up very often, but the key thing to remember here is a theorem called the Remainder Theorem, which basically states that when a polynomial evaluated at a, so polynomial p of a, right, is divided, when it's divided by x minus a, then the remainder is p of a. So that's kind of a rule. So because of this is called the remainder theorem. Because of this rule, when it's divided by x minus a, and a is the input, right, the remainder will therefore be p of a. That's just kind of a fact to remember. So therefore, D is the correct answer. All right, so question 30, we are given a parabola, right? And it says a parabola is just is given by this equation here, y equals x squared minus 2x minus 15, and it says, which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of the vertex A can be identified as constants in the equation. So this problem is a bit trickier. It's going to rely on a skill called completing the square, right? So what it means is that this is a form of parabola, right? Just like the equation of the circle that we talked about earlier, another form of a parabola is y is equal to x minus h squared plus k, where h is the vertex of the parabola, where h comma k is the vertex of the parabola. So we need to manipulate this equation into a form that looks like this and gives us a form that looks exactly like this. And then whatever the h and k come out to be as numbers, those will give us the coordinates of the vertex. So we need to use a technique called completing the square, which means that, and this is a bit more complicated, we need to somehow manipulate this expression to give us something that ends up in this form. So I'm just going to walk you guys through the process. And I'll kind of explain how I'm getting the result I'm getting. So we get y equals x squared minus 2x minus 15. What I'm going to do is I'm actually going to add 16 to this. And I'm also going to subtract 16. So I'm adding and subtracting something. That means it doesn't change my equation at all. But what this is going to allow me to do is to rewrite this equation as y is equal to x squared minus 2x plus 1 minus 16. And the reason I've done this is because when I go ahead and I look at my x squared minus 2x plus 1 portion of my equation, this is actually the same thing as x minus 1 squared, right? Because when I FOIL this out, this is just the same thing as x minus 1 times x minus 1. This is what I get, right? And so because of that, I can actually write my final equation in this form, right? By writing x minus 1 squared minus 16, right? And this is the form I was desiring to get. This is the same thing at the equation up here, right? But it's just in a different form. And now this equation, by the definition up here, allows me to get the vertex form I was looking for, right? To get the form I was looking for. So D here is the correct answer. If you're familiar with this form, you can pretty much rule out all the other answers because they're not in vertex form. C isn't, there's no square here, and there's an extra x, so C is incorrect. B is not in vertex form either. Assuming you knew this form, this would be an easier question, right? And A is not either, right? So that's just an important reason to know it. All right, let's take a look at question 31. It says, Wyatt can husk at least 12 dozen ears of corn per hour, and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time that it could take Wyatt to husk 72 dozen ears of corn per hour? So I'm just going to give a possible answer here. I'm going to assume that he's doing the least amount of husking for this. So let's see here. So he's husking 12 dozen ears of corn per hour. And how long is it going to take him to husk 72 dozen ears of corn? Then that's 72 dozen. We just divide that by 12, right? Because that's how many he's doing per hour. And that gives us 6 hours. That's how long it would take him total to husk that many ears of corn. So 6 would be a final answer. 4 is also an acceptable answer, again, because if you divide 72 by 18, you get 4. But also, any number between 4 and 6 is acceptable, right? Because it could be anywhere between 12 and 18. You could use 15, you could use 13, but I would stick with one of these answers because they're guaranteed to be nice. Okay, question 32 says, the posted weight limit for a covered wooden bridge in Pennsylvania is 600 pounds. So the limit is 600 pounds, 6,000 pounds. And we know that a delivery truck that is carrying X identical boxes that each weigh 14 pounds will pass over the bridge. So if the combined weight of the empty delivery truck and its driver is 4,500 pounds, then what is the maximum possible value for X that will keep the what's it called? Combined weight of everything at the limit. So we know the max weight is 6,000, right? And then we have 40. We want to sum together these two quantities, where 14x plus 45,000 equals 600. And we want to find, okay, what x makes this equal, right? Because if we make these equal, right, we know the limit is 6,000 pounds. We know that the truck already weighs 4,500, and we know that each box weighs 14 pounds. So whatever, we want to see how high we can make x to have it equal the weight limit, essentially. So that's what this equation is telling us, right? So let's go ahead and solve this. So if we solve this, we'll get 1,500 is equal to 14 x, right? It's equal to 14x. Yep. And if we were to, evaluate this equation, well, the closest possible value of x, right? The closest whole number value of x that satisfies this, it turns out to equal 107, right? You could verify that with your calculator. And so that is a solution, right? All we've done here is we've made these two things equal, right? And we found the lowest possible value of x to satisfy this, right? You want to round down in this case. That's something I should know, because if you round up, you may go over the limit. And, while that might be okay in a real life perspective, the problem isn't asking for that, and that could result in a slight error on the exam. All right, 33. So we're given this graph. It says the number of portable media players that are being sold worldwide each year from 2006 all the way up to 2011. Great. So it says, according to this line graph above, another graph question, the number of portable media players sold in 2008 is what fraction of the number sold in 2011? So in 2008, there are, again, it's just a rate, 100 media players sold, 100 million in 2008, right? And then in 2011, how many are there sold? Well, 160. So they want to know what fraction. Well, let's take the fraction of that, 100 divided by 160. Again, the millions will cancel out because they're both equal quantities. If we divide this out, well, we can divide them both by 20, because 100, we can do 100 divided by 20, and we can do 160 divided by 20, which will give us a ratio of 5/8. And again, that's what the problem asks for, just the ratio of those two quantities there. It's a good exercise in simplifying fractions, and the final answer is 5/8 or 5/8. All right, question 34. It says a local television station, it sells time slots for programs in 30-minute intervals. If the station operates 24 hours per day, every day of the week, what is the total number of 30-minute time slots the station can sell for 2 days, Tuesday and Wednesday? The dates are irrelevant. We just know it's 2 days. And they want to sell these 30-minute time slots. So there's 24 hours a day, right? So 30 minutes is a half hour. So based on the fact that they're half-hour intervals, they can do 2 of these per hour, right? And since there's 24 hours in a day, they can do 48 per day, right? Because that's 24 times day. And since we're talking about 2 days here, we'll just do 2 times 48, which is 96. 96 total slots they can book per day. All right, and that makes logical sense, right? Because there's nothing crazy jumping out at us in this problem. All it's basically asking us to do is some conversions, but assuming they were running for this whole time period, they could do 96. All right, here's a cylinder problem. So right off the bat, just going to write this formula. The volume of a cylinder is pi r squared times height, times the height of the cylinder. So it's good to remember that, because to keep that in mind. So then we have the other problem. So it says a dairy farmer uses a storage silo, the cylinder here, right? It's got two circular tops and a rectangular sides, right? In the shape of the right circular cylinder above. If the volume of the silo, right, is 72 pi cubic yards, then they want to find the diameter of the base. Okay. So in this equation, right, the volume of a cylinder is pi r squared times the height of the cylinder, right? This is the radius of the base. This is the r in this equation, right? And the diameter, what we're looking to solve for, is actually equal to twice the radius, right? Just like in a circle, the diameter is twice the radius. So we know the volume is 72 pi, right? And we know the equation of this, right? So we can set them equal to each other. Since this is the volume with r unknown, we also are given 8, and this is the volume solved out for us. So we can say pi r squared times the height, which is 8. The pi's will cancel on both sides because we can divide by pi on both sides. Then we divide 72 by 8. We get 72 divided by 8, which gives us 9. And that means that the radius is equal to 3. We're going to exclude the negative value there. And now that we know the radius is 3 based on this, again, all we did, they solved for the volume here. We set that equal to our volume formula here. This is also given at the beginning of the test booklet. And then to find the diameter, well, the diameter is twice the radius, so we'll just do 2 times 3, which gives us 6. Yeah, pretty straightforward, and a nice answer here too, which is nice. Almost done. All right, 36. 36 is a bit of a complicated one. It looks a little intimidating, but I promise it isn't. At least it isn't, assuming knowledge of a quadratic equation, right? They want to know, okay, so for what value of x is the function h above undefined? So what undefined here means, right, is that something is undefined if it doesn't have a value that makes sense. Like for a function to be undefined, it would have to have a value like 1 over 0, for example. When something when there's a number over 0, we consider this an undefined situation. And so to find the values of x where this is undefined, right, we're going to take this base here, this x minus 5 squared, this denominator, so to speak, 4 times x minus 5 plus 4, and we're going to set it equal to 0, right? Because if it equals 0, right, then this function, it doesn't have a real value, right? And so because of that, we know that it's going to be undefined when this equals 0, right? And even if we get solutions, right, we want to plug in both our solutions at the end to verify that which one makes it truly undefined. So once we solve this, right, we'll get a solution or two, right? Then we plug them back in the original function, and we see which solution actually makes it undefined, right? So let's go ahead and expand these. Since it's a square, right, this becomes x squared minus 10x plus 25 if you FOIL that out, right? And this becomes plus 4x minus 20. This becomes plus 4. This is equal to 0. So if we simplify this down, what do we get? We get x squared minus 6x plus 9 equals 0, right? And we got lucky, right? Because, well, if we look at this, we can actually factor this, make sure that's correct, yes, into x minus 3 times x minus 3, right? Right, because if we were to expand this out using the FOIL technique, right, we would get back to this. This is a perfectly reasonable thing to do. And now we see, oh, we're actually only going to get one solution, which is x is equal to 3. And if we take 3 and we plug it back in here to verify that we get an undefined result, right? So what do we get if we plug 3 back in here? We'll get, okay, negative 2 squared plus 4 times negative 2 plus 4. So that's 4 cancels, yep. Yep, does that make it up? Yes, and that produces an undefined result. Great, so x is equal to 3 will be your solution there. All right, the last two questions, 37 and 38. So they're referring to the following information. So it says, Jessica opened a bank account that earns 2% interest compounded annually. So it says she's initially depositing $100, right? And she's earning 2% interest per year, essentially. So whatever she has one year, the next year it's that plus 0.2% of that, and so on and so forth, right? It's compounding that annual, so it just takes sort of takes 2% of the previous year. So we want to find, okay, what is the value of x in this expression? This expression is incomplete, right? We need to find what x would be. Well, let's think about it, right? So if we take 100, right, and we make x 1.02, right? If we make x 1.02, and we think about this, right, after the first year, when t is equal to 1, then in her bank account she'll have 1.02%, right? So that's great. So we're building up, since 0.2 as a decimal, as a percent is 2%. We're building up 2% per year so far. So what if we do that again? We'll get 100 times 1.02, and again, when t is 2, we'll be doing it twice to the power of 2, right? This is taking 0.20% of this value, right? So if we plug in 0.02 for x, each year we're essentially taking 0.02% of the previous year, right? So this is also working. So therefore, for this to compound continuously, to compound annually, the value of x would have to be 0.02, which is essentially the same thing as saying 102%, but it's as a decimal. Remember, the conversion factor from percent to decimal, you divide a percent by 100 to get a decimal, and you multiply a decimal by 100 to get a percent. Great, so that's part one. So part two is generally a bit more complicated, but again, I'll write that equation we just came up with, that x is going to be important. Generally speaking, these problems use parts from the other, so that's going to be the power of t. And then, great, so this is the equation we just developed, right? So it says, Jessica's friend Tyshawn found an account that earns 2.5% interest compounded annually. So that's more than Jessica. So let's continue reading, actually. So Tyshawn makes an initial deposit of 100 into this account at the same time Jessica made a deposit of 100 into her account. After 10 years, how much more money will Tyshawn's initial deposit have earned? So to find Tyshawn's account, we can use the same process. So we have Jessica's account. This is saying 2% per year. Tyshawn makes the same initial deposit, right? He's compounding where t is the year, right? So it's the same exact thing as the example, but instead of earning 2% interest each year, he's earning 2.5%. So we'd represent that like this, and this makes logical sense, right? Because Jessica, she has her initial deposit of 100, and then she's compounding 2%, but Tyshawn here, he's got 2.5%. So instead of having a 1.02 here, we'd have a 1.025 here, because it's being compounded. It's the same exact parameters. Instead of 1.02, it's 1.025 because he's compounding 2.5% interest annually. So to compare, all we do is this. T is 10, right? To the power of 10, right? And then we do Tyshawn 1.025 to the power of 10, right? That's all we do. And we evaluate these, right? Let me just get my calculator here. And then what we do after that is we just subtract Tyshawn. Tyshawn is going to earn more because he's earning more interest, right? We subtract Tyshawn from Jessica, and then we can figure out the solution. So we'll have 1.025 raised to the power of 10. Do enter times 100. So Tyshawn is earning $128 at the end of that, approximately. Great. On the other hand, Jessica, we do 1.02 to the power of 10. We multiply that by 100. She's earning around 121.899. If you do the subtraction, and again, these numbers are rounded, you will get a result of 6.11 approximately. Yeah. So that would be the final answer. Let me just confirm that. Yes, 6.11. Great. Assuming the numbers were fully strung out, I rounded this off at the end, but it would be 6.1, right? This is how much more, and you can see it's kind of interesting, right? This is $7, right, by such a tiny difference. And it does actually make a difference. The 2.5% and the 2% produce pretty astonishingly different results. So it's kind of an interesting thing to note in this problem. So that's the end of the problem set. I hope everyone's doing well, and I'll see you guys in the next video.